Okay, so one important thing that we do is when we draw vectors, we draw coordinate systems to understand them better. So let's look at an example here of a coordinate system. We have a coordinate system is just two axes, and we label them X and Y. Typically, we have those two axes form a 90-degree angle, and then you measure, so you can take points here and then refers to points as pairs of X, Y points. So these are called Cartesian coordinates, and the important thing here is that we can represent vectors in Cartesian coordinates. Here we have a coordinate system. We have our X and a Y, and then we have a vector A. So this vector A is just a vector, and then we can define two vectors. We can define a vector AX and a vector AY, and these two vectors have the property that if you add them, you get the vector A. AX is a vector that is parallel to X, and AY is a vector that is parallel to Y. So then you get this property here, and we call AX the X component of the vector A, and we call AY the Y component of the vector Y. So this is the definition of vector components. Vector components are very important because they allow us to do algebra with vectors. When we add vectors, the easiest way you're going to see to do this is by using components. So to find the vector components, then you need to find the magnitude, and then you need to find these two vectors that are parallel to the axis, the vector AX and the vector AY. So an easy way to do that is by using trigonometry. Here we have, again, the same vector. We have a coordinate system XY and the vector A. And the vector A forms an angle theta with the x-axis, right? So we have this angle theta here. So now we see this is what we want. We want this vector A, and we want this vector Y. So this is AX vector, and this is AY. One way to get them is by realizing that this distance here, that is A cosine theta from trigonometry, right? Remember, if you have a triangle and this is the right triangle and this is theta here, this here is, and this is distance D, so this is D sine theta, and this is D cosine theta. So it's the same here. The X component is A cosine theta, and the Y component is A sine theta if this is your angle. So then with this trick now we can find the components of a given vector in a coordinate system, and that simplifies our lives a lot because now we can do algebra with vectors. If we know the components, we can go backwards, right? We can find this magnitude by using Pythagoras, right? And we can also find this angle by looking at the tangent of the vector, of the ratio between the components. So those are the things. So if you have the vector in a coordinate system, you can find the components, and if you have the components, you can find the vectors. Here is a question. So you have this coordinate system, and you have a vector there. So what are the components here? Take a minute. Well, if you look at this, then you can see that this distance here is 2, so that will be the X component, and this distance here from here to here, that is 3. That will be the Y component, so then 2, 3 would be your best answer. How about this one here? Why don't you take a minute to answer that? Again, if you look at this now, this is the X component here, and this distance here is the Y component. So then this is 3 minus 4, right? Because this is negative. So it's 3 minus 4, so that